Alright, here we're going to look at, in this video, one problem from Unit 5 and two problems from Unit 2. The problem from Unit 5 is going to be solving a equation that has fractions in it. So here, first thing you want to do is make sure that all the denominators are factored, but they are all currently factored. So now what you want to do is, in the first step, you want to get rid of all the fractions. So what we want to find is a least common denominator. So we're going to need something that's going to cancel with every single thing in the denominator. So here's an expression, x plus 2. So we're going to need an x plus 2 in our common denominator. Then here we already have the x plus 2, so we don't need another one. And then we have a 3 and a 6. So what's the common denominator for 3 and 6? That would be a 6, because a 3 will go into 6 evenly and a 6 will go into 6 evenly. And that's what we're looking for. We're looking to multiply through by something that will cancel with every single thing in the denominator so that we have no fractions left. Okay? So we're going to multiply the first fraction by x plus 2. The second fraction by x plus 2, and the last fraction by, these are 6x plus 2, 6x plus 2, and this one 6x plus 2. Okay, so then here in the first fraction we multiply the x plus 2 cancels with the x plus 2, which leaves you with 6 times 2, which is 12. Plus, here on this one, the x plus 2 cancels with the x plus 2, and the 3 cancels with the 6 and leaves you with a 2. So now we have a 2 times an x plus 3. And then in this last one, the 6 cancels with the 6, which leaves you with 1 times x plus 2, which is just x plus 2. Okay, so now we have no fractions left, so now we can just do the algebra. So here we're going to have to distribute. And this is going to get you 12 plus 2x plus 6 equals x plus 2. And so now we combined up like terms on each side. So this is 2x plus 12 and 6 is 18 equals x plus 2. So then the x can come over to this side, which just leaves you with an x, and the 18 can come over that side. So subtract 18 from 2, and you get negative 16. So there is your final answer. Now the only thing that you have to be careful of is it's possible that 16 might not work. So your domain on this one, remember you can't let your denominators equal to 0. So it looks like the only variable we have here is the x, which is attached to a 2. So x wouldn't be able to equal a negative 2, because negative 2 plus 2 would get you 0, and you can't have 0 in your denominator. Okay? So that's 38. On 39, here we want to solve this, but we have this square root there. So here we can get rid of the square root by squaring both sides. So if I square this side, that means I got to square this side. So here the square and the square root cancel, which leaves you with a 2x plus 3. And over here, I'm going to have to FOIL this out, because this is x minus 4 times x minus 4. Okay? Remember, you cannot distribute because this is subtraction. So now, let's just rewrite the left side. The right side, we are going to FOIL that out. X times x is x squared. Your outers is negative 4x. Your inners get you negative 4x. And your last terms get you positive 16. These can combine together. This gets you 2x plus 3 equals x squared minus 8x plus 16. Now, because we have an x squared left in the equation, that means we're going to have to set it equal to 0, because it's a quadratic. So I'm going to bring these terms over. So this is x squared. Subtract 2x from negative 8x, gets you negative 10x. And subtract 3 from 16, and that gets you 13. Okay. Now here on this one, are there factors of 13 that can get you 10? Doesn't look like it, because the only factors of 13 are 1 and 13, and there's no way to get a 10 out of that. So that means we're going to have to use the quadratic formula. So x equals, remember this, there's a 1 here, so that's our a, our b, and our c. So this is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, opposite of b would be positive 10 plus or minus the square root of negative 10 squared minus 4 times a was 1, times c, which is 13, all over 2 times a, and a was 1. So here x equals 10 plus or minus the square root. Negative 10 squared is 100. Negative 4 times 1 is negative 4. Negative 4 times 13, what's that? 4 times 13, that's 52. So this is minus 52 all over 2 times 1, which is 2. So then x equals 10 plus or minus, this is the square root of 48. It's 48. 100 minus 52 is 48 over 2. But then that can reduce. So x equals 10 plus or minus, perfect square in 48 is 16. This is 16 times 3. So square root of 16 is 4. Square root of 3 over 2. And now 10, 4, and 2 all have a common factor of 2. So this is going to be 5 plus or minus 2 square root of 3. And then 2 goes into 1, so we don't have any denominator. So here is your answer for x. However, the negative version of this, when you plug it back in for x, we need to see here if we can't have a number smaller than 4 here, because the square root can't equal a negative number, so this number can't be smaller than 4. So let's check to see if either of these numbers are smaller than 4. So this is 5 plus the square root, plus 2 square root of 3. Let's see what that comes out to. That's 8.4, so that one's okay. But then if I change this to a minus, what happens? I get 1.5. So if this is 1.5 minus 4, that's going to be a negative number. Square root can't equal a negative, so your only answer, the negative, is extraneous. So really the final answer is 5 plus 2 square root of 3. That's your final answer. Okay? Because the negative is extraneous. Okay? On number 40, same problem, except here we don't have multiple terms over here. We just have a 5. So this one should be much easier. We can get rid of the square root by squaring both sides. That cancel, leaves you with 3x plus 4 equals 25. So 3x equals, bring the 4 over, you get 21. So then x equals 7. Okay? And since there's no x over on the right hand side, there's no chance that this one's not going to work. So x equals 7 on that one.